Good morning, everyone. All right, that's good. My name is Luca Bolognese. I'm a lead program manager for the LINQ team from the LINQ project and C#. As a lead program manager, I am kind of a level of management between people doing the real job and another level of management on top of me. So, yeah, so the LINQ project, why we think it's so important, why we are so excited about it. You have about 15 or 20 presentations, maybe less, maybe more, about LINQ in this TechEd. So we really think we are solving a big problem with LINQ. It's this kind of impedance mismatch between your objects and your data. If you're a programmer these days and you write code, your experience it's pleasurable. You write code, you can set breakpoints. If you do something wrong, the compiler is going to pop up and tell you. When you hit dot, you see IntelliSense, so you know what to call. You can debug into your code. You can do all those things. It's like driving on a Ferrari. You're on the Autobahn. You're driving very fast, and with the wind in your hair. If you have a convertible Ferrari, I guess So it's a pleasure. It's a good time to be a programmer these days. The problem comes when you have to access data. Then your experience suddenly becomes much worse. Suddenly there is this, let's take, for example, a database. There is this black box in a corner of the room, and the way you talk to this black box is through strings. You send the strings, and this guy sends you back some rectangular structure that is not even strongly typed, and the compiler is not there to help you. You cannot debug inside. There is no IntelliSense. It's like you are going back to 10 years ago to assembler programming somehow. And the situation is not much better if you are working with XML. It's like in my previous kind of image of driving with a Ferrari, is like if suddenly you crash or but you survive. Yeah, so essentially your experience is much worse. At the same time, working with data has some very positive things going for. For example, the concept of queries. The concept of this more declarative way to work with your stuff. In your programming languages, you are always there, creating a new list, adding list, for reaching over things. While when you work with data, you just submit queries and you get results, which is kind of a beautiful way to work with things. So what the LINQ project tries to do, and I obviously think we succeeded, but you will be the judge, is to merge those two domains so that you can now work with data with the same pleasure than when you work with objects in memory, and at the same time, all of those things like queries that were available in the domain of data now are available inside your program. Okay, you guys with me? So that's kind of the goal of the LINQ project, and I'm going to talk for another hour on this slide. So okay, so how does it work? This is my last slide, and I have demos from now on. So the first things we did, very first thing we did is to introduce queries as first-class citizen in the .NET framework. So essentially, now you can talk about this concept of a query in .NET. Once you have queries, you can start surfacing this notion inside your programming languages. So now in C# or VB, you can query over things. So you have query inside the language itself, but what you can query against. And there are a number of things that we are kind of producing for Orcas. One of them is objects. If you think about this, objects in memory are data. You know, they have fields, they have relationships, and they compose themselves. It's like having a little database in memory. And so it makes perfect sense to query over your collection. And if you really think about it, you are already doing it. I mean, wherever you for each over a collection and you extract elements from this collection, you are querying. It's just that you are doing it in a very imperative way. You are telling the compiler exactly, you know, what to do. But you are already querying. The other obvious domain when you might want to query is a relational database. And we have, so if you wish, we LINQ enabled ADO.NET, which means that we now support queries over data sets in memory and over relational database, over relational database. And we have two frameworks to query over relational database. One is LINQ to SQL, which provides you a very direct way to access your database. If you have a kind of a simple mapping framework between your objects and your database, then LINQ to SQL is a very fast way to get to your data. And then there is LINQ to entities that provides a more complex kind of mapping, a more rich kind of mapping. So if your object model is very different from your database, then LINQ to entities is indeed the way to go. And the third kind of big block is LINQ to XML. So all those queries that works against objects and works against relational database, they work against XML as well. Are you guys got your coffee today? I feel like, okay, let's go. So it's all a big demo from now on. So hopefully I can wake you up somehow. All right, you might not realize it, but this is Visual Studio. And you can put Visual Studio in this state by going to Tool Options and unchecking a whole bunch of stuff. Not that I suggest that you do it, but it's very good for demos at least. If you want to know exactly how to do it, just drop to our kind of booth, and Karen, that is our IDE PM, she's going to show you. And she has a presentation as well, not on this though. And I'm also using snippets. How many of you know what snippets are? Okay, yeah. Snippets are essentially a way for me to write just one word and a whole bunch of text or code kind of comes along. And notice that the compiler thinks that this is a keyword. So I'm going to use snippets because I have this. Whoa. All right. I have this slight accent, you may have noticed. And so if you guys did? I always hope to keep it hidden, but it kind of comes out. So if I write all the code, then I write too fast and I speak, and you guys have no idea what I'm talking about. Assuming that you now do, but yeah. So my application is going to work like this. I'm going to write my whole application in C# 2.0, and then I'm going to convert it to C# 3.0 to bring home the points that I introduced before. So let me start with this. So my application is going to manipulate customers. So I have my customer class. Notice that it has customer ID, contact name, and city. Then I'm going to create a driver with a static void main, like so. And then I need a way to load my customers. I want to have a collection of those customers. So I create a customer list. And notice what I'm doing. I'm creating a new list, creating one customer, setting the property, and adding it to the list. I'm doing this a bunch of times, and then I'm returning this list of customers. Okay, so now by calling load customers, I'm going to have a list of customers. What I want to do with this application, I want to print out a report that has all the cities that starts with the letter M and all the number of customers that there are for each one of those cities. Imagine I'm building a website and this is one of the pages on my website. All right, so I need something to represent my result. Okay, so I need a result class. And my result has a string that will be the city and the count, which the number of customers for this particular city. So let's write the code to achieve that. So I need a list of results. Let's call it results. Equal new. Notice that IntelliSense already knows that this is a list of results. So I can go and do this. I can for each over all the customers in my load customers collection. Then if the customer has a city that starts with M, for example, it works even with different letters. Right? Just to let you know. Yeah, if I have this, then I want to do something slightly more complex that I'm going to explain to you in a second. I'm going to look if inside my collection of results there is already a result that has the city for this particular customer that I'm iterating on. If there is not such a result, that means that this is the first time that I find this city. Then I create a new result. I set the city, I set the count, and then I add this result to my list of results. If there is already a result with this particular city, then I just increment the count property for that particular result. So once I'm done, I can simply print all my results out, like so. So let's see if I made any error, as I often do. So this is my result of my query. You will see those are all the cities that starts with M, and this is the number of customers for each one of those cities. Allow me to use something slightly more sophisticated to print out this. It's a little object I wrote called object dumper, and what it does, it does exactly the same things that my for each loop was doing. It just for each over all the results and print them out. Nothing strange there. It's just that the printing is much more pleasing, as you can. It has some colors, anyway. All right, so this is how I write this code in C# 2.0. You might think that you might use a dictionary and write it in a slightly better way, but this is about the code that you have to write to achieve this. Now let's see what C# 3.0 does for you in this case. So first of all, I need a bunch of usings. I don't need all those usings for LINQ. The only one that I need is this, but I'm introducing all of them so that then during all my demos I don't need to add using all the time. So, okay. So notice this customer here. Notice that what I'm doing there is not particularly smart. I mean, I just have fields and I'm exposing them with getters and setters, but there is no business logic associated with it. So I can just, in the new version of C#, we allow you just to specify this, and we generate the getters and setters under the cover automatically. Then let's take a look at, I knew you would like that one. Yeah, so let's look at this. You have the type here in two places. You have before the equal operator and after the equal operator, and this is slightly redundant. You would think that you can write this code in a simpler way, and we allow you to do so by saying var, and the compiler automatically will put a list of results there. In fact, if I put my thing over there, you will see that this is indeed a list of type of result. But I don't need to tell the compiler twice. I just need to tell it once. This is another small thing we did, and you can do the same thing here in your for each loop, and indeed you see that, you know, the compiler knows that this is a customer, so when it compiles this code, it's going to put customer there instead of var. It's just that you as a programmer, you don't need to specify it. All right, let's take a look at this piece here. This is a delegate. Delegates are a way to pass functions to other, well, it's to create something that represents a function. The problem with delegates is that the syntax is somehow inconvenient. It's very long and you know, unpleasing to the eye. So we have a kind of a better syntax now. And you can say, you can do this, cast.city equal c.city. This is called, now I'm going to say the wrong term. We used to call them lambda expressions. And I think we still call them like that, but not exactly sure. But it's I should have figured that out before. So this is a better syntax to write delegates, much easier to read, kind of thing. And notice I'm kind of going through my code and simplifying it. Notice here I'm creating a result, setting the city, doing all those things, and we allow you a better syntax for doing that. Noting what I'm doing, I'm creating a new object of type result, and I'm assigning the properties on the fly without a need for all that code that I had before. This is a convenient way to initialize an object all in one single line of code. And now that you can initialize objects like that, you might want to initialize collections the same way without writing all this code that I have here. And indeed, you can. This is called collection initializer. Notice how I create a new collection, and I immediately initialize all its field. I've kind of put items inside the collection, and I'm also using object initializer for all those items. So essentially to create a complex collection like this one, for example, it's all one single line of code now. You don't need to do all the rest. All right, so we made our code somehow simpler. Let's see if it still runs or if I made any error. Well, it still runs as before, so those are real features. It's not like I made them up. So if you are looking at, if you have been paying attention, you would feel somehow cheated at this point. You will feel like, okay, you just introduced a nice thing here, a nice thing there, but you haven't really changed the way that I write code. Those are just incremental steps. It's nothing nothing fundamental. And you would be very right. And in fact, the main problem with this code is this, right? The problem with this code is that I'm being very imperative. I've been telling the compiler, hey, create a new list, iterate over this stuff. If this equals that, then starts. You know, you are there composing things at a very low level of granularity. You really want a better way to write that code. And we think we have a better way for you. The way to write that code now is like this. You do from C in load customers, where c.city.startSuite, M, group C by c.city, and let's group into a variable called G. And let's select out a bunch of results where city is equal to g.key and count is equal to g.count. Like so. See if it works. Haha, it doesn't. Because here I need it's a query. Yeah, indeed it still works. Notice what we did here. This is vaguely reminds you of kind of SQL, so that it's easy to understand. There are a couple of differences, but right now I want you to think about this in a slightly different way, and think about those clauses coming one after the other, where the from clause gives you back a sequence, a collection of objects. Then after the from clause, you apply the where clause. And the where clause takes a collection as an input and gives you back another collection that contains a subset of those objects. After the where clause, you apply the group clause. The group clause takes a bunch of objects and groups them and returns you a collection of a different type that is a group of the other objects. And after that, you apply the select clause. And the select clause, again, takes a collection and returns you another collection of a different type, a collection of results, in this case, composed by taking things from the previous collection. If you are familiar with relational algebra, this is just a concatenation of operators, each one of them taking a collection and returning a collection. If you're interested in how this works under the cover, there is a wonderful presentation by my buddy Luc Hoban that will go in excruciating details, in a good way, a good excruciating, of how this all works under the cover. I believe it is on Thursday, if you guys are interested. I have no time now to go in all the details. Something else that I want you to focus on is the return result of this function. This function returns an enumerable of t. And because it returns an enumerable of t, then it can be queried using LINQ. So all the collections in .NET are enumerable of t. And almost all the libraries that you guys work on, when they have to return collection of stuff, return enumerable of t's. So without any change to any part of your code, you can now use query over all your libraries. Indeed, you can use queries over reflection. And we haven't changed the reflection in any way. It's just because methods in reflection returns enumerable of t. And this whole machinery is triggered by enumerable of t. You guys with me? Yeah? All right. There is still something unpleasing about this code. what is unpleasing is this. So notice that result is not a part of my domain. I don't have any business object called result. I have customer, I have orders, but I need to create a result just for the sake of representing the return type for my queries. Imagine if I have hundreds of queries in my application, I will have to create hundreds of those temporary types, and this is very inconvenient. So let's remove it. See if it works. I like the suspense. All right, let's remove results, and it still does work. The trick here is this piece. This is called anonymous type. What happens is, if you don't specify the type for something, like in that case, the compiler under the cover is going to create a type, give it a crazy name that you cannot, you don't need to know, essentially. But the point is that you don't need to create new types that have no sense for your domain just for the sake of submitting queries. Okay? All right, there is still something in this code that it's not really realistic, and that's it. I mean, most of the time you're just loading data from external sources. You're not just kind of embedding your data inside your program. So let's see how we can write this in a slightly more realistic way. I happen to have an XML file that has all the data for my customers. So let's see how I can read my data from that XML file. So there is a new component in LINQ called LINQ to XML, and I will be using that to load that data. And I will be using a query. So I will say from X in xelement.load, and I will be loading customers.xml, .elements. I'm loading all the elements named customer. And from those, I'm selecting out new customers. So I will say new customer, city equal x.attribute. You notice that all the data was in attributes there. So I can say city.value. And contact name, x.attribute. Contact name dot value. And I can do this and this. And this is all I have to write to load data from my XML file and to return a collection of objects out of it. So if I run this, you will see the same data as before, but this time I load in this data from my XML file. This is using XLINQ. When you have a query in your programming language, when you have queries, everything becomes very fluid. You can get data, get it from something, put it in something else, transform it, and do all those things in a single line of code, as I'm doing here. This is LINQ to XML used to parse an XML file and returning objects out of it. Okay, but let's say that you already have an application that returns